Hello and welcome back to my workshop. My name is Robert. It's been a while since I last posted a video. Holidays, life in general, and the amount of time it took me to do the project that is the subject of this video are partly to blame. In this video, which is part 1 of 2, I make a grinding attachment for my shaper, similar in idea to a tool post grinder for a lathe. Why would be a good question. The answer is I'd like to be able to accurately grind an involute tooth shape, and I don't have any other way of achieving that at the moment. If some parts of this video seem a bit disconnected, that's because during the editing I had a brain fart moment and managed to delete all of the only copy of the footage I had. I got it back using some freely downloadable software called Recover. I'd like to stress that I'm not being paid to endorse this software in any way, shape or form, but I'm very grateful for it. It managed to get back 95% of the footage for no financial outlay, so thank you to them. Okay, let's get on with the video. I'll put together a collection of bits here, and the intention of all of this is finally to get a grinding wheel like this, driven by a motor, for example this one, and mount it on the shaper. Now to this end I've got this motor, which it belonged originally to the Taylor Hobson lathe. This was the original feed motor for the table. I've removed the gearbox from it because I don't want it to operate at 108 revs per minute. I'd like it to go a bit quicker for the grinding wheel. I've got a couple of tooth belt pulleys that were kicking around from a long ago project that never happened, and a belt that goes with it. So the idea is to somehow mount the motor, mount a spindle and drive the spindle with the motor. The motor is a goodness knows what power single phase job, and it's a bit of a vintage one. I have the electrics that I put together a while ago for a different project in a box here, all nicely earthed and kept nice and safe. So the electric side of stuff is done. I've got a piece of aluminium bar here which I might well use for a housing for the spindle. And I've got a choice of a couple of bits of rod here, steel, which I'll use for the spindle itself. There's also a piece of aluminium plate, 3/4 plate, which I'm intending to hold the whole lot together with. How exactly it goes on the shaper is still TBD, but we'll sort of get there bit by bit by bit. So I'm going to start off by moving the grinding wheel somewhere safe. I'm going to start by probably fly cutting this piece of plate smooth. Now for the 3-hole pattern to mount the spindle, centre at 0, 0, diameter in this case is 1.5 inches, and there are 3 holes, and the start angle now will be 60 degrees. So we start 60 and we finish at 300. Right. So for the uninitiated, 0 mathematically is usually assumed to be at 3 o'clock. So that's 0. And I want my first hole at 60 degrees there. Second one over here, third one over here. They'll obviously be closer in than that. So that's at 60 degrees up, because it's 120 degrees between holes. And this one is 60 degrees away from 360, so it's 300 degrees. That's why I put those figures in. So there we are, there's the motor secured. So I'll finish this plate. I've got 4 holes in here to mount the motor on as well. So now we come on to the spindle housing and the spindle. So I've got my little scribbly drawings here. Well, these were done on Design Spark, so they're not quite so scribbly. This is the spindle. So this end here goes in the housing. It's 5/8 of an inch because the bearings that I've got kicking around are 5/8 of an inch, and there's a spacer tube to go between them, so as they're angular contacts it keeps the spacing. Then we've got a little section here at pretty much 3/4 inch diameter, whatever the stock is. Then we've got another 5/8 register. This is where I'll put the pulley on, the belt drive pulley, and then a 1/2 inch spindle out here. This will be threaded on the end. Now this is going to match the hardware that I've got for my tool and cutter grinder, so that I can mount this, use the same mounting hardware for the wheels, etc., to put the wheels on. Kind of makes sense. So the length of this is a little bit unknown at this stage. The exact positioning of this register is unknown. So what I'm going to do is to cut probably about 9 inches or more of rod, and I'll prepare this end. I'll put a centre in both ends, and I'll turn it between centres anyway. I'll turn this end because then I can use this end to poke the bearing into the housing. Now the housing itself is nothing more complicated than a tube. Just cross section through it. This is going to be slightly bigger than 3/4, otherwise the spindle will foul on it. But it's 2 inches diameter because that's what stock I've got, and 5 inches long seems reasonable. That's the same length as the motor, so I can get the bearings about here and here. It's not shown on here, but I'm going to thread the end of it and put a screwed in nut and a wavy washer, which I've also got to make, to preload the bearings very slightly. Now the way I'm going to run this is I'm going to have the cones of the angular contacts facing outwards with the spacer in between, so the cones cannot move inwards, and then the outside races will be a sliding fit in here. So this is going to be a bit of a challenge for me, trying to bore something 4.5 inches deep, keeping it nice and parallel, given that my lathe bed is a bit wonky. But I think I can do it, because I think the carriage will be further to the right on the bed, where the bed is not quite so worn. So I think this will be all right. So first job will be to start with the spindle. It's a bit of a weird looking arrangement, but it'll drive it. Finally get to use the drive pin on the dog drive plate that the collet chuck is mounted on. The finish from that CCMT insert leaves much to be desired. It's probably absolutely knackered, but for just roughing down that little bit, it's better. Now I'll just clean it up with this DCGT insert and get this to exact size. That finishes okay. Over, 5.5 over, 5 over. So it looks like there's going to be a degree of polishing involved here. 4.5. Looks like the lathe bed wear is coming into play here. Yeah. So it's half a thou between there and there, but a thou between there and there. The joys of an old lathe. Right. Shade under there. Bang on. Bang on. It looks to me like that's parallel. That's good. That's as close as I'm going to get to it. Right, so now I'll come to cutting a thread on the end here for a lock nut. I'm going to cut a 5/8 UNEF 24 TPI thread because it's sort of a standard and I just sort of thought that might be quite good. This is the full range of threads that this lathe will cut without changing, without putting new change wheels in it. We want 24 threads per inch is C6SY, which is the lathe into neutral first, make it easier to get these in. There we go. And that should be set up for 24 TPI. And there's your 24 pitch gauge, and that lines up absolutely perfectly. Good. So that's 630 and a few tenths or so, which is pretty much where I wanted to be actually. That feels nicer. That's nice. I'm going to put a couple of spanner flats on this lock nut now. There it is. Absolutely perfect. that'll fit very nicely. Right, housing next. That's 5¼ inches. I need 5. So this is my 5¼ inches long piece of stock, which is going to become the housing. I've got it dialed in. It's within about 1 thou there, and if I come down to about there, the needle's just sort of wiggling a little bit, but not very much, less than 1 thou. It's raw stock as well, so it's probably not going to be perfect, is it? It's not ground or anything. So that's dialed in as good as I can get. This end is going to become the end that bolts onto the plate. So I need to drill the hole that's going to be the clearance hole for the spindle. So this is going to end up being a 3/4, which will then be reamed out slightly bigger. I'm going to drill in a fair old way to avoid having to drill the other way all the way. This will get faced, and then the whole thing can get flipped, and I'll bore it from the other side. So the back side, which will then be here, I'll bore that 4½ inches in, which will be the interesting part. Not that there'll be anything to see, but it'll be an experience. So I've got it flipped round, dialed in again, and it's not bad end to end. That's what, 1/2 thou out across a couple of inches there. That'll do. Good. Well, this is going to be a bit of an experiment. This is stuck out 4 5/8 inches. I need to bore 4½ inches deep. This is a 16mm steel boring bar. We'll see how we get on. And we've got about 1/2 inch to take out of this, so there's quite a lot to come out. This is a threading bar. It's not a boring bar. and the end of this insert will be straight across, so it's going to be pretty horrible when it hits the bottom. However, it's a good bit more rigid than the previous one, so we might get away with getting this in there. So I'm finally beginning to win with this bar. It cuts without chatter at 540 RPM, 8 thou per rev feed. Probably the design is the biggest problem. I'm trying to make a bore this long, but it looks like it's working. So I'll carry on. I do have to make a couple of design changes though. Let me introduce you to them. So this is my very simple sketch of what I'm just trying to make, just in cross section. Now the first problem is this thing's going to go in here like that. Obviously this isn't to scale. I need a little bit of relief for this section just here of this bearing. So just this part is going to contact. So I need to remove this bit here. So there'll only be a small step here. So this bearing will sit around here. So I'm thinking of taking out a few thou along here to match up with this gap between here, because this bit doesn't matter, it's not doing anything. So that will make it easier to actually hit the size on this bore here and here, and similarly this bit here, and this bit won't matter at all, which will make life much easier given the wear on my lathe. The other thing that needs doing is a thread needs cutting back here, and the size of that thread is determined by the diameter of the bearing. So the ID of this thread will be no smaller than obviously the OD of the bearing. We'll get there eventually. Come on, you've been in there already, that's it. Well, it's just about there now. I've got a wodge of steel wool around a piece of copper tube here, acting as a hone. So we'll give it another go. It's a little bit tighter than I want because the other bearing's got to slide all the way through. So I'll get it going in until this bearing goes into about the right depth, and then I'll recess the middle, and then we'll tackle the back end. That's the sort of fit I want. There we go. So now I've got to do the clearance in the middle first. Let's get that out. can see the bore and you can see the step, and down at the back there's another step where what will be the front bearing rather than the rear bearing will be. That feels all right. That's it. That's it. That's a bit of an abrupt end, but the next segment fell victim to my stupidity. I'll end the video here as it's long enough already. I'll carry on with the build and test in part 2. Hope you enjoyed it. Thanks for watching.